To Nation Innovation. Now today we will describe about the topic which is known as system. Okay, so basically we are given a system defined by, let's suppose this is a system. Okay, here we are giving a input in the form of which is a continuous signal. Okay, input, this is our input, and we are getting a continuous output naming y of t. This is output. Okay, so what basically a system does? So basically a system performs certain operations on a input x of t to produce output y of t. Okay, this is y of t. Okay, now let's move forward to understand more about systems. So let's suppose we are having a system which we are doing a mod of square. So this is x of t and this is y of t. Okay, so let's suppose x of t is equal to a sine omega naught t. So what will be our y of t? Y of t will be a sine omega naught t ka whole square. Okay, so this will be a square sine square omega naught t. If we further solve it, this we can call it as 1 minus cos square omega naught t. So what basically a system is performing? It is doing a square operation on x of t, and we are getting an output y of t. Okay, this is basic operation of a system. Now let's discuss about the properties of a system. There are namely 6 properties of a system. This we are discussing here, the properties of a system. Okay, so, so the first is static and dynamic system. Static and dynamic system. Second one is causal, non-causal, and anti-causal system. The third one is time variant, and invariant system. Variant and invariant system. The fourth one is linear and non-linear system. The fifth one is stable and unstable system. And the last one is vertical and invertible systems. Okay, now let's move forward to the first type of a signal. So our first type of a signal is system in static and dynamic system. Okay, static and dynamic system. So basically this static system is memory less system. Now I'll discuss what is memory less and what is with memory system. This is memory less and this is dynamic system is with memory system. Okay, so memory less system basically means the present output depends on present input. Okay, now I'll make you understand how the present output is depending upon present input and how the present output is not depending upon the present input. Okay, so I'll take one example here. Let's suppose y of t is equal to x of t ka whole square. Okay, so if I'll calculate at t is equal to 0, at t is equal to 0, this y of 0 will be equal to x of 0 ka whole square. This y of 1 will be equal to x of 1 ka whole square. Okay, so we can easily see that y of 0 is depending upon x of 0, y of 1 is depending upon x of 1. Okay, so this is our static system. This is our static system. Now take another example. Okay, now let's take another example. Y of t is equal to x of t ka whole square. Now for t is equal to 0, if I check, then y of 0 is equal to x of 0. Okay, here till here we can say that it may be static. May be static. Okay, we cannot confirm it can may be static. But if I check for y equal to 1, again we can say that it can be static. It can be static. Okay, can be static. Now as I go for t equal to 2, I'll get x of 4. Okay, if I go for y of 3, I'll get x of 9. So we can see that, okay, it is depending on future. It is depending on future. So this is our dynamic system. It is storing the memory of future also. So this is our dynamic system. I hope I have made you easily understood this static as well as dynamic system. Okay, now let's move forward to second type of a system. Okay, which is, now let's make a table. Causal. Okay, this will be non-causal, and here this will be anti-causal. Anti-causal system. So in the causal system, if the present output if the present output depends on the present input or present plus future input, then it is called as a causal system. Now coming to the non-causal, if the present output if the present output depends on the if the present output depends on the present plus future or present plus past plus future input or the past plus future input, then a given system is the non-causal system. Okay, now for the anti-causal, if the present output depends on depends on the fu- depends on sorry depends on the future input, then it is anti-causal. Now let's take an example to understand these causal, non-causal, anti-causal clearly. Okay, so now if I take an example here, let's take y of t is equal to x of t ka whole square. Okay, so we have seen earlier only that this is a static system. This is a static system, which means the present output depend on present input. Okay, so we can clearly say from here that static systems are causal systems. Okay, this is the systems. Okay, so this is the most important result of our discussion. Okay, Now let's take another example to understand non-causal. If I take another example, let's suppose y of t is equal to x of t square. So here y of 0 will be equal to x of 0, y of 1 will be equal to x of 1, but y of minus 1 will be equal to x of 1. That means it is depending upon present plus future also. Okay, so it is future. So this is a non-causal system. Okay, this is a non-causal system. Now let's take another example to understand anti-causal systems. Okay, so now if I take y of t, this is equal to x of t square plus 1. Now if I go for y of 0, this will definitely be y of 1. If I go for y of 1, this will be x of 2. Okay, so we can clearly say here that it is depending upon future input. This is depending upon future input. Hence, this is anti-causal system. Okay, so till now we have discussed two types of a system. Now let's move forward to understand time variant and time invariant type of a system. Okay, so the third is time variant and invariant. Time variant and invariant. Okay, so in invariant system, now I'll take an example to make you understand easily that what is time variant and time. Now we are writing a definition to understand it better. So if the time shift in the input results in identical time shift in output, without changing the nature of output, then it is called as time invariant. Okay, then it is called as time invariant. Now let's take an example to understand better about time variancy and time invariancy. Okay, so I'll teach you a shortcut method to easily prove this. So let's take y of t is equal to x of t square. First, I'll make a change in the output. If I make a change in the output, this y of t minus shift, if I shift for t naught, will be equal to x of t minus t naught ka whole square. Okay, this will be whole square. Let's name it as equation number 1. Now if I'm making a change in the output, okay, now if I'm making a change in the input, if I'm making a change in the input, so if I'm this y of t minus t naught will be equal to x of t square minus of t naught. Okay, so if I compare equation 1 with equation 2, these are not equal. So this is time, this is varying with time. So this is time variant system. Okay, this is a basic shortcut to understand this time variancy and time invariancy. Okay, now let's take another example to understand better about time invariance and invariancy. Now let's take y of t is equal to x square of t. So if I make a change in output, okay, clearly see I'm making the same steps only. Y of t minus t naught is equal to x square of t minus t naught. Okay, and let name it as equation number 1. Now if I make a change in input, then y of t minus t naught, it will again be equal to t minus t naught, because there is no operation on. So this 1 is equal to 2. So this is time invariant, because there is no operation on t. That is why only we are getting time invariant system. Okay. Now let's take another example. So another example will be, let's take y of t is equal to t times of x of t. So if I make a change in y output, I am following the basic steps only. I am not making it hectic. So this will be t minus t naught x of t minus t naught. Okay, name it as equation number 1. Now if I make a change in input, I'll get y of t minus t naught will be equal to t x of t minus t naught. So we can clearly see from here that 1 is not equal to 2. So this is varying with time. Okay, this is time variant system. Okay, so till now we have seen the three types of system. First one was static and dynamic. Second was causal, non-causal, anti-causal. Third one was time variant and time invariant. Now the another three types I'll be discussing in the next lecture. Okay, thank you.